Now let's take a look at a service bus queue and how we interact with it.
I'm going to take you on a tour of the configuration and use of service bus queues. Now I've already got a service bus queue set up, and honestly I already have the code to interact with it, but I'm going to walk through both of those just so you can get a feel for what the service bus queue is. I'm going to go through the same demonstration that I went through using a storage queue, and you'll see that there's an awful lot of commonality. The approach that I use with service bus queues is going to be pretty much the same as the approach that I used with the storage queues. Now, obviously, they have different capabilities and somewhat different architectures, but also to an extent, queuing is queuing. All right, so let's take a look at our service bus queue. Notice that I'm in the classic portal. So this is still an Azure Services Management Model functionality. And I've got a queue set up. And so I go in here, and this is actually a namespace. In NCG demo is the namespace. And then I set up a queue named demo within the namespace. And if we look at that, it has not been particularly hard hit today. Now, I will say that in general, the graph here, the usage graph, does not update terribly quickly. What we do want to take a look at is that I've got a queue length right now of 0. All right, so I've got a queue, but I've got a queue length of 0. Now let's take a look at the code that I'm going to use to interact with that. First of all, I'm going to go down to the bottom of my code where I've got a class chat request, which again is sort of, if you saw the storage queue demo, the idea being that we have a customer service center and people can request live chats and those go into a queue. And so really the information related to the chat is really completely not important. What is important is that I do have this public class chat request. Now also, I have marked this class with the serializable attribute because the storage queue will actually go through its own serialization process. With the the service bus queue goes through its own serialization. When I use the storage queue, I had to actually set up the serialization myself, which I did through JSON. This is actually going to use XML serialization. Okay, so here is what we have. I've got the ability to generate requests. That has nothing to do with the actual queue. That's just setting up some objects that I'm going to work on with the queue. All right, then I connect to the queue, and I use a process pretty similar to what I did with the storage bus or the storage queue. I get a connection string, which is right here. Here is my SB connection, and it's got a different format. I was able to get that connection, by the way, through the portal. And I get the connection, and then I use that to create a queue client from the connection string. Okay. Now, as far as interacting with the queue itself, once I've got the queue, I simply send. I can use client.send. Now, I need to send a new brokered message. I use a request object, so I'm cycling through each of those 3 chat request objects that I created, and I'm sending those as the object that's being brokered. As long as the object is serializable, which is why I had to mark it serializable, then you can make it basically the payload of a brokered message. Now, the brokered message also has, and I'm going to just do this really quickly. I did that just as quickly as I could. So var msg1, because I have another msg. Oh, I'm just having all kinds of trouble. There we go. Var msg1 equals new brokered message request. Now, one of the cool things about this is that I've got a properties collection. It's actually a dictionary, and you can add your own custom properties into a message. That was really all I wanted to do there, was to show you that. All right, and so if you want custom properties added in dynamically, I can absolutely do that with a storage bus queue. In any case, I didn't do that. I just wanted to pop my objects onto the queue. All right, then what I do, if I want to receive those messages or pull those messages back down, I use the client.receive. Now, when I use a client.receive, it's listening for the next message that's available, whether it's there already or it's going to wait for it. And as such, I have to specify that I want a timeout period. And that's this new time span. That's just setting a 10-second timeout period for that receive. Otherwise, after it had already read the 3 messages that are already going to be there, it's just going to kind of sit there. All right, so basically, if it doesn't receive anything, it returns a null, so I test to make sure that that's not equal to null. All right, and if there is a message, if it does get a message, then I retrieve the request object from the body of the message using the get body, and that's a generic, so I specify that it's going to be of type chat request. So it's going to do the deserialization for me, and then I write it out, and then I have to mark on line 51 that the message is complete, and then when I'm done, I use console.writeLine. Now I'm going to put a break in here, and I'm going to go ahead and run this. Keep moving my mouse over things that are giving me IntelliSense and kind of making that a little interesting. Sorry about that. Okay, so it has now sent the messages. So theoretically now, we go out and go back in, scroll down. It says that I've got 3 messages in the queue, and the current size of the queue is 1.36 kilobytes. So really massive storage on the queue there. Okay, but there are messages on the queue. Okay, now what I'm going to do is I'm going to go ahead and run through these. And you can't see anything, of course, because the window's down below, but here's the, oops, almost. There we go. There is the result. So it pulled back, and that's just the chat request from logged at. Okay, those are just the 2 strings of the message itself. The point is that I was able to pull the message back and print the message out. Okay, so that's one way that you can use the message queue. The message queue has a pretty cool feature that goes beyond, say, what the storage queue can do, in that I can set up a listener on the service bus queue. Get rid of this guy here. I love regions. If I can remember how to use them, I love regions. There we go. All right, so I'm going to come up here to part 2. And what I'm going to do is I'm going to set up an event-based listener for the queue. Okay. And so here I've got an options on message options. Okay. And that's going to be a options object I use to configure my queue listener. Basically, it's an event-based architecture that lets me register a listener, so when messages are dropped into a queue, I can automatically pull those off, right? So if you've got a service that's waiting for messages, instead of having to say, turn the service on and periodically pull the message, I can actually set up a listener on the queue that's going to have an event-based approach to listening to it. Okay. And the way I do that is I've got a client, and this happens to be the same client I'm going to use to send. Usually that wouldn't be the case. I was just too lazy to create a second one. And I set up the on message method, and I send it a function, okay, really a delegate. And I'm using, if you are familiar with Lambda expressions, right, the on message expects a delegate that accepts one parameter, which is the message. And so I'm defining that directly in the on message method itself. And if you're not familiar with Lambda expressions and delegates, that can be a little bit confusing. But essentially all I'm saying is, look, when the client receives a message, or when the queue receives a message, I'm registering the client to do this with the message. Okay? And so really what I'm doing here is exactly the same thing that I was doing with the other message, or with the other approach. I'm just writing it out, but now I'm writing it out as it is received. Okay, I'm going to do a couple of other things. put in there sending messages. And I'm going to put a breakpoint here because I want to run this and show you what happens. Okay, so I'm going to pull this up and see if I can't get both of these things showing at the same time. That's what I was looking for. There we go. Okay, so I can see that it says sending messages. And if I scroll down here, I'm at the for each. And so now what I'm going to do is I'm going to go ahead and step through this, which I really wish. There we go. So it goes through, sends. Now, notice what happened in the background there. The chat requests, 2 chat requests actually were processed, right? So if you look over here, it's not happening, it's actually happening asynchronously, but I am getting those messages and they are getting processed. And if I run this out, it's actually kind of cool. The process itself says it's done, right? So it comes down here to the done before the last one is read. So as long as I don't close this, I'm still listening. Even though all my code has run, I'm still listening for messages in the queue, right? And again, you can see it. The done is the last statement that runs here, but that last chat request comes in after that, which is, I think, actually a pretty cool concept. And it's just something to think about. You know, if you've got a queuing architecture, if you've got you want to have that decoupled architecture, but you don't want to have a polling system where a service has to continuously connect up and see if anything's there. You do have that ability to register a listener and, you know, just as messages come in, automatically process those messages.
Understand the fundamental difference between the storage queue being string-based, a little bit smaller, and also the fact that it's potentially a longer-term storage as opposed to the service bus queue, which is going to be more object-based and it's more of a traditional queue approach.